How do I do this? My name is Lashonol.
I love how straightforward that question was. It's like, I really don't understand. How do I do this? And to be honest, I looked at it and I thought, I don't know how a matric would do this, because I know how a varsity student would do this question, because they have all these rules and things that you can apply to calculus. But as a matric student, first principles sucks. There's one way you can do it. It's an equation. So let me try and help you through this question. It says, differentiate using first principles. So we know that we have to use the definition using limits and stuff. It seems straightforward. It's literally just f of x is equal to the square root of x. Okay, so we know that f of x is equal to x to the power of a half. Okay, so it seems pretty straightforward, but let's try and expand this. We know that in order to find the first derivative, f prime of x is equal to, we take the limit as h tends to 0 of f of x plus h minus the original function f of x all over h. So let's plug in our function. So we're still taking the limit as h tends to 0. F of x plus h. So basically whenever you see an x in the original function, you substitute x plus h. So instead of x to the half, we have x plus h to the half minus the original function, which is just x to the power of a half all over h. Now, usually you would try and expand this and then find a way to cancel out the h's so that you don't have a 0 denominator. But how do you expand this? I know in varsity and add maths you would use binomial expansion, which basically says that you have something to the power, it's going to give you this many terms, and it tells you how to figure out what the terms are. But in matric, how do you expand something to the power of a half? How do you expand the square root of x plus h? You don't. There's a plus in the middle. How do you even go about doing this? Okay, so the aim of working with this limit, we need to get it so that there's no h in the denominator that would cause a 0 denominator when we take the limit. Because remember, divided by 0 is going to give us an undefined answer. So we need to look at this and try and find an expression that will maybe relate the h to the numerator. So remember, we're still taking the limit of as h tends to 0. If I say to you, just on a side note, if I have y, and then I add 1 to y, but I want it to stay the same, obviously I have to subtract that 1, because 1 minus 1 is 0, and we're still going to be stuck with y. Same as if I have a, if I add 10 to a and I still want to be left with a, I need to subtract 10. What I'm getting at is, if we want to try and cancel this h out, we need to express it in terms of the h in the numerator, okay? So, if I add x, let's first of all write the numerator. Nothing's going to change in the numerator for now. If I add x to h to give me this x plus h, to keep this numerator or the denominator the same, because we have to maintain the integrity of the denominator, we still have to subtract x, because you agree with me, x plus h minus x is still h. It's just written as sort of like an expanded form. But now we can relate this denominator to the numerator, okay? So, another trick, this is actually a very sort of set proof of the first derivative of this function. The numerator is still not going to change, x plus h to the half minus x to the half. Another thing that we need to take note of, if I have two squares minus each other and I want to factorize them, obviously I get x plus y multiplied by x minus y. So the rule is you square root both of them, and then you put the square roots on either side of a plus and minus bracket. So if I wanted to try and square root this denominator, obviously you don't recognize these as squares, but if I want to try and square root the denominator, obviously I'm going to have two brackets with a plus and a minus in them. The rule is you square the first term, you square root the first term. So we get the square root of x plus h, and we square root the second term. So we get plus the square root of x. Do the same thing and separate them by a minus this time. So if I multiply these two out, these brackets, I'm going to be left with this denominator here. Okay, the whole reason we're doing this is to try and find how we can cancel the h out in the denominator. So remember, these halves here as exponents are basically the same as saying the square root. So now do you see we've been able to express the numerator and denominator in terms of each other? This whole numerator is exactly the same as this whole bracket here. They can divide into each other to give us 1. So we're still taking the limit because we haven't substitute h as 0 into anything yet. This whole numerator was divided by this factor of the denominator to give us 1, so it's still 1 over, but now we just have that first bracket, the square root of x plus h plus the square root of x. And now do you see, if we take the limit as h tends to 0, we're not going to have anything divided by 0, because if we substitute h tends to 0 into this expression, we're going to get 1 over the square root of x plus 0, because as h tends to 0, you add 0 plus the square root of x, okay? Which gives us 1 over root x plus root x, which is equal to 1 over 2 square roots of x. Now if you go right back, remember we have f of x is equal to the square root of x, which is equal to x to the power of half. If we applied just our differentiation rules, remember you multiply by the exponent, so you get a half, and then you subtract 1 from the exponent. So a half minus 1 is negative a half, which means that we're going to have 1 over 2x to the half, which is the same as 1 over 2 square root of x. Okay, so when you get a question like this, where you have no way of expanding the numerator so that you can cancel the h in the denominator, because remember first principles, you're trying to get that h away from the denominator because you don't want it over 0. The moment you can't expand the numerator, try and relate the denominator to the numerator so that you have factors that can divide into each other. Ultimately, all you're trying to do is prove that the first derivative you get by differentiation rules is the derivative you get by applying first principles.